All right, now we're going to talk about proofs. Sounds daunting. It's really just listing your logical thought process while thinking through something. So before we actually talk about the specifics of it, we need to talk about some properties. So these are things you might already be familiar with. Properties of equality. The addition property of equality says that if A equals B and C equals D, you can write A plus C equals B plus D. Now, that's a lot of letters. It's something very simple, and you use this all the time in algebra, and you should be familiar with it, but you may have never seen it look like this. So all it's saying is that if I have some equation, I can add the same thing to both sides, which you've done already. You know how to do that. This is just the mathematical, very specific way of stating a property. So if you have 3x minus 4 equals 16, you know you can add 4 to both sides. That's algebra. You know that, but this is just stating it formally. So the addition property of equality says you can add the same thing to both sides. The subtraction property of equality says you can subtract the same thing from both sides. The multiplication property of equality says you can multiply both sides by the same thing. And the division property of equality says you can divide both sides by the same thing, as long as you're not dividing by 0. You shouldn't divide by 0. You're not in calculus yet, so don't worry about that. Yeah, so the first 4 is algebra. Nothing super involved there. The substitution property of equality says that if A and B are equal, then either A or B may be substituted for the other in any equation, or that should be or inequality. So what does this mean? Well, if I tell you that x is 7 and you have an equation that has x in it, you can substitute 7 for x every instance x shows up. That's all this is saying, is that if I know the value of A, and if I know like A is 7, I can substitute 7 in for A for every instance of A. It's substitution. This says it in a lot of words, because that's how math has to do things. You have to be very specific. The reflexive property of equality is the most redundant, in my opinion, is that something is equal to itself. Kind of obvious. But it's a statement. It's called the reflexive property of equality. The symmetric property of equality is another thing that we use all the time we just use it without knowing about it. The symmetric property of equality says that if A equals B, then B equals A. You can just flip an equation around. You can do it with inequalities too, but you have to make sure you flip the sign. So if it's greater than, it changes to less than, which is something like that. But the symmetric property of equality is super easy, because if you know that 4 equals x, you know x equals 4. You could just flip an equation and nothing changes. The transitive property of equality says that if A equals B and B equals C, then A equals C. That's another thing. Then if A is the same as B and B is the same as C, then A and C have to be the same thing. That's all it's saying. So if I know that 4x equals 3 and 3 is the same as 7x minus 13, then 4x equals 7x minus 13. You could just put, if two things equal the same thing, they equal each other. Different ways of thinking of it. The distributive property of equality, it's distribution. You know how to distribute things. I'm not going to belabor that one. Yes, I am. If you have C times the quantity A plus B, it's C times A plus C times B. You distribute the C to both addends. You distribute the factor of C to both addends of A plus B. There's also properties of congruence. This is the congruence symbol, if we haven't gone over that yet. So the reflexive property of congruence says that things are congruent to itself. Now, what is the difference between the reflexive property of congruence and the reflexive property of equality? Well, it's really just this symbol in between. And the symbol is very important, that as far as equality is concerned, numbers are equal to each other. But in geometry, we deal with shapes a lot, and shapes are congruent. They are the same. They have the same properties, the same length, the same angle measured, the same size, the same things. But if you're talking about numbers, then they're equal. but if they are shapes or geometric objects, then we use the congruence sign. So really the properties of congruence are extremely similar to the property of equality, just we use a congruence sign in objects instead of an equal sign in numbers. So the symmetric property of congruence says that if D is congruent, if segment DE is congruent to segment FG, then segment FG is congruent to segment DE. Again, you can flip a congruence. You can also, with segments or angles or really anything else that can be measured. The transitive property, if one segment is congruent to another one, and that one's congruent to a third one, then the first one is congruent to the third one. Same thing with angles. If two angles are congruent and two other angles are congruent, but these two are the same, then the first is congruent to the last. It's the properties of congruence. So let's see how these would be used. This is called a two-column proof, because there should be columns here. The first column is your statement, and the second column is the reason that you're doing that statement. Now, 99 times out of 100, the first reason should be given, and the first statement should be just kind of what you start out with. So if I have 3x plus 17 minus 4 equals 4x minus 1, my first step would be to combine like terms. So this would be 20x minus 4 equals 4x minus 1. Now, why did I do that? Why was I allowed to do that? Well, that's just addition. 3x plus 17x is 20x. It's just addition. That is the reason that I did that. My next step would maybe be to subtract 4x from both sides. So really I don't want to show work inside of a statement or inside of a proof, so all I would say was if I were to subtract 4x from both sides, I would end with 16x minus 4 equals negative 1. Now this is the subtractive property, or subtraction property of equality. Because I subtracted 4x from both sides. I thought I added for a second. No, I totally subtracted 4x from both sides. So this is my statement, and this is why I have that statement. My next step would maybe be add 4 to both sides. So 16x equals negative 1 plus 4 should be 3. So 16x equals 3. What did I do? I added. I added 4 to both sides, so that would be the addition property of equality. And my last step would be to divide both sides by 16. So x equals 3/16. And that's the division property of equality. So this is an example of a two-column algebraic proof where I'm starting with what I'm given, and then as I go through algebraically, I would combine like terms. Well, to do that, I used addition. Next, I would subtract 4x from both sides. That's subtraction property of equality. The subtraction property of equality is I can subtract the same thing from both sides and it stays equal. So using subtraction, everything stays equal. Then I added 4 to both sides. The addition property of equality. I added the same thing to both sides and it stayed equal. Last thing was I divided both sides by 16. That's division property of equality. Yeah. So you're not always going to use all of the properties in every proof. It's kind of pick and choose which ones you want to use. And these could be in different order. Like these two can switch places. My statements would be a little different, but those two could absolutely switch places. I would still end up with x equals 3/16. We'll confuse things. Let's look at the next one. Now this is a proof that we're supposed to prove that vertical angles are congruent. So in the end, I want to show that angle 1 is congruent to angle 3. Well, really all I'm given is this diagram. So I know that angle 1 and angle 2 are supplementary. So I can say that angle 1 plus angle 2 has to equal 180 degrees. Why? Because they form a linear pair. Can I say they're supplementary? Not really, because I don't know they're supplementary. I know they form a linear pair. Now that I know that they form a linear pair, now I know they're supplementary. But we don't really need to know that yet. Same thing with angle 2 and angle 3. Angle 2 plus angle 3 have to equal 180 degrees. They also form a linear pair. Now, since both of these equal 180, they equal each other. So angle 1 plus angle 2 equals angle 2 plus angle 3. Now, there's a little debate in my head as to what property this actually is, because in my head, you could use the transitive property and say that since this equals 180 and 180 equals that, they equal each other. That's the transitive property. However, we're not really using the transitive property because we're reading this one backwards. So if we used the symmetric property first and flipped this, then we would be able to use the transitive property. However, that is not the transitive property since we flipped that. So really what this is going to be is substitution. So we started with this equation, and we know that 180 equals this, so I can substitute this in for 180. So this is substitution. Now, my next step would be to say that angle 1 equals angle 3. And that's really what I'm trying to end with. So my last statement would be, well, my question is, what did I do there? I used subtraction. So the subtraction property of equality, and really I am missing something in all of these, is that I'm not talking angle 1 plus angle 2 equals 180 degrees. That actually doesn't make any sense, but the measure of angle 1 and the measure of angle 2 equals 180. And the measure of angle 2 plus the measure of angle 3 is 180. And the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. So the measure of angle 1 equals the measure of angle 3. Now, because we want angles are congruent, we don't want the measures to be equal, we want the angles to be congruent, there's one more step, which would be that angle 1 is congruent to angle 3, and that's just the definition of congruence. And that's proofs. Proofs can be frustrating at times, and really they are for me. It just takes a lot of practice. That it's the logical process of the steps, because really, I mean, you can probably look at this, you might be able to look at this and say, well, obviously 1 and 3 are congruent. I mean, they're vertical angles. That's like the definition of vertical angles is they're congruent. Well, this is why they're congruent. I mean, somebody didn't just wake up one morning and say, well, yeah, vertical angles are congruent. It's a theorem. It's provable. And we just proved it. So it's really something you just got to practice, and practice we shall. Absolutely.